Hi GUR, this is Unit 6, Lesson 3, and today we're going to use trig ratios to find missing sides of a triangle. So if you're looking at the first example that I have triangle ABC on the left and I have triangle DEF on the right. The angles in both the triangles are 30, 60, and 90. Okay, so their angles are congruent, which means that they're actually similar to each other. Remember, that was one way to prove triangles were similar, by angle. So using the diagram, let's find the ratio of sine of A. So I'm going to look at A, and remember SOHCAHTOA. Sine is opposite over hypotenuse. So the sine of A is going to be opposite, which is 5, over hypotenuse, which is 10. And that reduces to 1/2. And then I'm going to do the sine of D. So again, now I'm looking at D. And sine is opposite, which is 7, over hypotenuse, which is 14, which also reduces to 1/2. So what do you notice? I notice that they are the same. Triangles are similar, so their sides are in proportion. Okay, triangles are similar by angle. So that means the sides are in proportion. And that's basically why these trig functions work. So the calculator has all of these ratios stored in them, and we're going to start using our calculator today to find the missing sides of things. So very super important is that your calculator needs to be in degree mode in order to calculate trig ratios. So if you go to your calculator, I have one here, and the normal, when you reset your calculator, is going to be in radians. So if you hit the mode button right here, see how it's in radians? I'm going to scoot down to and over to the right, and I'm going to hit enter. I want it to be in degrees. So make sure that your calculator, where you have a calculator, an actual TI-84, or using this app on your phone, it was called Calculate 84. Make sure your calculator is in degree mode. All right, so let's start finding some of these trig ratios. Using the calculator, we're going to find the sine and cosine of these different angles. So if I do sine of 0, I'm going to do sine of 0, 10, 20, 30, 40, 50, and so on. So let me just show you a couple, and then we'll write them down. So if I go to my calculator, all right, I'm going to hit sine. So the sine button is right here. It's 2 above the 7. Let me just clear this. Second quit. Okay, so sine of 0 is 0. Sine of 10 is, and this is an irrational number, goes on and on. We're just going to write the first four numbers, 0.1736. I'm going to find the sine of 20, the sine of 30, which is 0.5 or 1/2, the sine of 40, okay, 0.6427, the sine of 50, 0.7660, the sine of 60, 0.8660, and the sine of 70, 0.9396, and the sine of 80, 0.9848, and the sine of 90. And that's where we're going to stop. And the sine of 90 is 1. Okay? And then we're going to do all of these for cosine also. We're going to write them down. So cosine of 0 is 1. The cosine of 10 is 0.9848. Now remember what we learned. The cosine of 10 is the same thing as the sine of 90, 0.9848. All right? And the cosine of 20 is going to be the sine of 70. The cosine of 30 is going to be the sine of 60. All right, so let's go back and we'll write these down in our notes. So the sine of 0 was 0, 10 was 0.1736, 20 was 0.3420, 30 was 0.5, 40 is 0.6428, 50 was 0.7660, 60 is 0.8660, 70 is 0.93977, 80 was 0.9848, and 90 was 1. And the cosine of 0 is 1. The cosine of 10 was the same thing as the sine of 80, 0.9848. Remember that these are the same. The cosine of 20 is going to be the sine of 70. You can check it in your calculator. The cosine of 30 is the same as the sine of 60. Cosine of 40 is the same thing as the sine of 50. So this is just the reverse. Cosine of 60 is the same as sine of 30, which is a half. This was 0.3420, 0.1736, and 0. All right, so let's actually do a real problem. Using trig ratios, let's find the length of side A to the nearest hundredth. All right, so here's what I got. I'm going to use this angle right here as 40 as my reference angle. So if I'm using 40 as my reference angle, this is opposite and this is hypotenuse. Therefore, I'm going to use sine. Remember, SOHCAHTOA. So the sine of 40 equals opposite, which is A, over hypotenuse, which is 26. Now you can find the sine of 40, we have it right up here, 0.6428, and then you can cross multiply. So, or I like to actually cross multiply and get the variable by itself and then put it into my calculator. So basically I put a 1 under sine of 40, 1 times A is A, and then I have sine of 40 times 26. So I can do that in my calculator. I already did sine of 40, it was 0.6428 times 26. And I want to find this to the nearest hundredth is 16.71. Okay, so we use trig to find the missing sides of a right triangle, just like we use Pythagorean theorem, but Pythagorean theorem is more limited because I have to be given 2 of the sides in order to find the third side. Trig, I can give, as long as I have the angle and 1 of the sides, I can find the missing sides. All right, so same thing, I want to find the length of side B to the nearest hundredth. So now I'm trying to find B. Let me switch colors here. So I'm trying to find B. This is adjacent. So I got adjacent and hypotenuse. So therefore I'm going to use cosine. Cosine of 40 equals adjacent over hypotenuse. Put a 1 under here, cross multiply. 1 times B is B. Cosine of 40 times 26. Cosine of 40, I can look at my chart right here, but I would just really just do it in my calculator. 0.7660 times 26, and that gives me 19.92. What method other than trig could be used to determine the length of side B? Well, I already mentioned this, Pythagorean theorem. Once I know what side A is, I can use side A and the hypotenuse in order to find side B. So that would basically be 16.71 squared plus B squared equals 26 squared. All right, and if I do this in my calculator, I actually wind up getting the same answer, 19.92. Okay, let's look at the next page. So we just have some triangles. The biggest thing you're going to have to do is to figure out which trig ratio you are going to use, and that's based on what sides that I have. So as soon as I have this angle right here, I can label the sides. So this is my hypotenuse, and this is opposite. So since I have opposite and hypotenuse, I'm going to use sine. Sine, the angle is the very next thing to come. Sine of 42 equals x, opposite over hypotenuse. Put a 1 under here, cross multiply. 1 times x is x. Sine of 42 times 18. So that's what's going in your calculator. Let's do one together so you can see the calculator. So I'm going to do sine of 42, close the parentheses, times 18. And all of these are going to be rounded to the nearest hundredth, so it's going to be 12.04. Done. Okay, so I'm going to highlight the angle, number 2. I'm going to label the sides. This is hypotenuse because it's across from the right angle. This is adjacent. Since I have adjacent and hypotenuse, I'm going to use cosine. So cosine of 28 equals adjacent over hypotenuse. Now this one's just going to be a tiny bit trickier because when you cross multiply, I have cosine of 28 times x equals 1 times 6. So I don't have x by itself. I need to divide by cosine of 28 in order to get x by itself. So in my calculator, I'm actually doing 6 divided by cosine of 28. All right, so calculator, I got 6 divided by cosine of 28. And that's 6.795, and I have to round that to the nearest hundredth, so it's actually going to be 6.80. All right, 6.80. All right, number 3, let's start with highlighting the angle, labeling the sides. This is adjacent, this is opposite, this is hypotenuse. I don't have the hypotenuse, so I'm not going to use the hypotenuse. I'm using adjacent and opposite, therefore I'm going to use tangent. So tangent of 63 equals opposite over adjacent. I'm going to put a 1 under here, cross multiply. 1 times x is x. And then I have tangent of 63 times 34. All right, so this one I have x by itself, and this whole thing goes into my calculator right here. Tangent of 63, close the parentheses, times 34. And you're going to round it to the nearest hundredth, 66.73. Number 4, here's my angle. This is the hypotenuse. This is opposite. So I'm going to use sine because I have opposite and hypotenuse. So sine of 50 equals opposite over hypotenuse. Put a 1 under here, cross multiply. So sine of 50 times x equals 123. So this is the one that's going to take an extra step. I have to divide by sine of 50. So in your calculator, you're going to do 123 divided by sine of 50. 123 divided by sine of 50. And you're going to get, make sure you round it to the nearest hundredth, 160.57. Okay, and then we got one more problem left. So this is a real life kind of example. I have a hot air balloon, and I want to find out to the nearest foot how high it is above the ground. So I'm trying to determine the height. Height is always going to be a vertical line. I'm trying to find the height of this hot air balloon. Okay, so I know the angle right here is 50. I know the string that I have right here is 110. So lots of times I have problems like this with kites. This one happens to be a hot air balloon. So this is my angle. And this side is opposite and this side is hypotenuse. So I'm going to use sine because I have opposite and hypotenuse. So sine, the angle is 50. Opposite, which is x, hypotenuse is 110. I put a 1 under here and I cross multiply. 1 times x is x. Then I got sine of 50 times 110. Make sure you're closing the parentheses around the 50. Sine of 50 times 110. And you're going to do that in your calculator. Let me just do that right here. So sine of 50, close the parenthesis, times 110. And this one, they want me to round it to the nearest, what is it? I don't have this one on my paper. 84.264. Let's see how I'm rounding it off. To the nearest foot, 84.26. So to the nearest foot is just 84 feet. Okay, and determine the distance to the nearest foot on the ground between the two ropes. So now I'm trying to find this distance right here. At this time, you can either do trig again, or you could do the Pythagorean theorem, whichever you want. So if you want to do trig, this is adjacent, so I would do cosine. Cosine of 50 equals y over 110. Put a 1 under here. 1 times y is y, and I got cosine of 50 times 110. All right, and I'm going to do that in my calculator. So cosine of 50 times 110. Let me just pull up my, I'm just going to do it on my calculator right here that's next to me. So cosine of 50, you guys do it at the same time. All right, so cosine, close the parentheses after you hit cosine of 50 times 110. 70.7. All right, and the nearest foot. So since I get 70.7, it's going to be 71 feet. All right, and we will practice all of that again tomorrow.